Okay, time for another example video. And this is an example about velocity and position. So the example reads as follows. The question reads as follows. If a particle's position is given by this expression, which is quadratic in the time t, x here is in units of meters, time in units of seconds, what is the velocity at time equals 1 second? Okay, well, we know from the lectures that the definition of velocity is the rate of change of position with respect to time, or dx by dt. So we can just substitute in our expression for x. So we will get the derivative of 4 minus 12t plus 3t squared with respect to time. And we know how to differentiate functions of this form. Okay, this is just a polynomial, so we take each of the terms in turn. So the derivative of this constant term here will be 0. The derivative of this linear term here will give us minus 12. And the derivative of this quadratic term here will give us plus 6t. So that's the equation for the velocity. And then we want the velocity at a specific instant, at time equals 1 second. And so we get that just by substituting in t equals 1. And this then gives us minus 12 plus 6, it's minus 6 meters per second. Okay, it's meters per second because this dx here is in units of meters, and this dt here is in units of seconds. So it's meters per second. Okay, that's the first part. The second part of the question then says, is it moving in the positive or negative direction just at that point t equals 1? Well, we find that our velocity is given by minus 6 meters per second. And we can see that the direction of this vector then is pointed in the negative x direction. So it's moving in the negative x direction at that moment in time. Okay. Next part, what is its speed? Well, the speed, so again, let's just write down what the velocity is. So the velocity is minus 6 meters per second. The speed is just the magnitude of the velocity. So it's the magnitude of minus 6 meters per second. And the magnitude of minus 6 meters per second is just 6 meters per second. So we have this vector quantity, minus 6 meters per second is the velocity. What that means, and what these two bits of the question we're getting at, is that we're moving in the negative x direction. So that's the direction of our vector. And the magnitude of our vector then is 6 meters per second. That's the speed. Okay, more complicated question then. Is the speed increasing or decreasing just then? So we have an expression for our velocity, which is this minus 12 plus 6t. That's the expression that we derived for the velocity in the first part of the question. And we will learn in later lectures that when we talk about speed increasing or decreasing, what we're talking about is acceleration. But actually an easier way of solving this question just to begin with is to graph these quantities. So let's do that. Let's make a plot of our velocity as a function of time. And what this function looks like, well, we know that at t equals 0, so if I substitute in t equals 0 here, I get a velocity of minus 12 at time equals 0. And then if I substitute in a value of t equals 1, which is what we did for our for all of the previous parts of this question, well, t equals 1, I get minus 12 plus 6. So we know that that's minus 6 at t equals 1. I could keep going, I would find that, if t equals 2, then this quantity equals 0. What I end up with is a straight line going through these points. And that's just the straight line described by this equation, minus 12 plus 6t. So the question is the velocity, is the speed increasing or decreasing at this point? And it's an interesting question, right? Because the velocity is increasing, i.e. this line, or the value of this line, is getting larger and larger. But remember that the speed is the magnitude of this velocity. And if I plot the magnitude of this velocity, okay, let's do that in a different colored line. So I'll do that in this yellow line. The magnitude of the velocity looks something like this. Okay, because it's just the size of this thing. So at this point, it's equal to 12, and then at this point, it's equal to 6, and so on. So the speed is actually decreasing. Okay. So what's actually happening here is that the particle is moving in the negative direction, but it's slowing down. So this morning in the lecture, what I did was I walked across the front of the lecture room, and then I turned around. So I sort of slowed down, and then I turned around and came back in the other direction. So my velocity was doing something like this. Or sorry, my speed was doing something like this, but my velocity was doing something more like this because I was getting moving. I was always kind of accelerating in the same direction back towards the bench. So that's just a little tricky subtlety here. The velocity is increasing, that's this red line here, but the speed is actually decreasing, i.e. we're getting closer to the x-axis, or the time axis there. Okay, last part then, it says, is there ever an instant when the velocity is 0? Well, we've actually just drawn it there. We've drawn that our velocity passes through 0 at a time t equals 2. So we know that that's the case, so yes, v at t equals 2 equals 0. We can verify that with the mathematics. So v is equal to minus 12 plus 6t. And clearly, when I substitute in t equals 2, I get 0. Okay, so yes, at time equals 2. Oops, sorry. At time equals 2, I get a velocity of 0. And the final part of the question, is there a time after time is 3 seconds when the particle is moving in the negative direction? Well, I think we can see again from this graph that this velocity is just going to keep increasing with increasing time. So if the speed is getting greater and greater and greater, and it never changes direction, then no, we'll never again return to a velocity of 0. Another way of saying that is that the only root of this equation, the only time that this equation is equal to 0, is precisely at the point t equals 2. So the answer to this question is no. After t equals 2 seconds, the velocity continually increases. Okay, and so it only has this one root. Okay, so that's the basic idea. Again, this is kind of maybe might be oversimple. You might think that this is we're kind of going through all of this detail for no reason, but as we'll see when we start to look at vector quantities, where we look at motion in 2 dimensions, having this rigorous way of doing things will make our lives a lot easier. Okay.